What you can see is that we have at the moment 500 terawatt hours electricity production in Germany. About 50% of it is renewable. So most of the increase needs to be driven by solar and wind, even in Germany. Use different semiconductor materials, make tandem solar cells, triple solar cells, so to put them on top of each other, and then you can increase efficiencies. And one of the, let's say, most promising materials are so-called metal organic perovskite. So this is a new hybrid semiconductor, or rather new hybrid semiconductor. So you can put it in addition to the mainstream technology as an add-on technology. And with this, you can go to so-called tandem solar cells. But from the efficiency side, going to tandem triple junctions, this would open up also a new path for PV and for certainly all what Robert needs later on, cheap electricity to do all the chemistry which is needed.
We found that wind's variability is not white noise, right? White noise has the same amplitude at all frequencies. So the question is, what happens when we add some of these plants together? Does it smooth the fluctuations out? When we talk about smoothing, the time scale is very important. As I mentioned, 12 hours has a whole lot less smoothing than an hour. The second is the point of diminishing returns from connecting wind plants together is very quickly reached. You get almost to the asymptote after about a half a dozen wind plants are added together. So what about solar? We know that the insolation curve is modulated by clouds, and you get these fast and deep fluctuations. And we've found the same sort of power spectra, except there are a lot more harmonics of 24 hours, as you might expect for the power spectrum of PV. But again, the amount of smoothing achieved with 20 plants is about the same as you get with 10 plants. So what about solar thermal? We expect that the thermal inertia of the working fluid in a solar thermal plant will help smooth the fluctuations. I asked the question of what's that cost? Using the ancillary service prices in California, we can say that integrating wind and solar thermal costs $4 or $5 per megawatt hour, and it's about double that to integrate solar PV. It's entirely achievable.
So why do we focus on heat in Germany? Because the electricity production is challenging at a low temperature, and we recently got a new law, the new building energy law, and one of the elements of this law is that all communities have to do a heat planning. And the vision of Germany, of the German government, is that we will have 42% of the German buildings heated in future through district heating. The issue or the problem, the challenge is that this is heat which is located to specific areas in Germany. The solution which we follow is that we look into large volume and high temperature heat storage. And there is a solution, a new technology, which is called EGS technology, which we follow since a few years already. If we want to include these two technologies, then we can talk about 500 terawatt hours in 2045.